So let's evaluate the user info from the REPL, and bam, perfect. Hi. Okay, the first thing is that I have shadow-cljs set up here. So if I type something and reload it, you can see that it works. If I manually evaluate it, that also works. Perfect. I have an index.html file here where I have a div ID app. So let's get that. I'm going to use the document.getElementById and evaluate that. Now we want to create this board structure here, which is 30 cells. So let's create the cells first. I'm using document.createElement to create a div, and then I'm going to set its class to .cell. And last we'll return the cell. Let's try to print the cell out and see if it actually creates a div or not. And you can see we've got our div class cell. That's perfect. Now we are going to create a board, and let's give it total number of cells. Okay, before we add cells to the board, let's try to evaluate this and see if it works. And you can see we've got our div class board, but if we open it and we see there are no child nodes here. So let's add those. But first, let's try it in the REPL and see how this will work. So let's create a comment section. Let me store a reference to this board element. And then let's call append child with a make cell call. So we still don't see the board element in our HTML structure. So let's append board to app as well. Okay, when we do that, we can see that we've got the board and the cell elements. And now we can keep appending cell elements. And every time we evaluate this, we can see that the cells get added. So to complete our make board function, we just want to create n cells and then append them to it. So now you can see that I really need to evaluate these comments again and again. So let's fix that. Let's add a function mount. Let's create the board here and append this to app. Let's also get rid of the app global and pull this inside our mount function. Oh, there's a bug here. Let's not forget to add board. Let's call mount now. And we can see that our app, our board, and our 30 cells have been populated. Let's improve the styling of these cells so we can see something here. Let's go to our index.html and let's add a style tag. I'm using a grid of 5 columns. Hopefully that works. And giving each cell a fixed width and height of 50 pixels. Let's refresh and let's mount again. Perfect. Let's remove the need to mount again manually every single time. So let's bring it out. Let's get rid of the comment and let's save this again. And now you see that shadow-cljs kind of adds this state again, everything. And every time we save this, it's going to append it once more. So we don't want this to happen. So let's fix this. Let's create a function called as unmount. And let's set the inner HTML of app to empty. And now we can call unmount and then mount. And let's save this. Perfect. Let's write something in these cells now. So let's create a function write letter, which takes a reference to a cell and it takes a letter. And what we can do is we can set the text content property of the cell to the letter. Let's test this out now. Let's initialize all the cells with a particular letter. And we can't see the text clearly now. Let's give it a color. Let's improve the styling a bit. Okay, so to write the cell letters, we need a reference to the cell. So let's create a state. Let's create an atom to house all of the state. Let the atom be a list of the 30 cells. So when we create the cell, let's add the cell to the board state. So we are going to swap this atom and conj the cell reference. So now we are holding a DOM element reference inside our atom, and that is fine since we only have 30 elements. So let's try to save, and let's try to access the board state now. Okay, we can see these elements. Let's take the first element from the board state and let's write a letter onto this element. So let's write A. Perfect. Can we write something to the second element? Yes, we can. And okay, so now let's add an event listener so that we can take input from the user. And we want to do this on the document so that we pick up the event from anywhere. And let's see how this event looks. So I'm not saving now, I'm just evaluating this so that it gets attached. And let's try clicking something here now. And we can see that when I press A, I can see an event with key of A. That's all we really need. So when we get an event, let's call another function called as user input and pass it the key. So what we can do is, instead of, since event is a JavaScript object, what we want to do is get this attribute. So we are going to do ./key on event. Another thing which I'm going to do here is that when I hit Shift A, you can see that I get a capital letter. And let's say when I hit enter and when I hit backspace, I get these E capital, B capital. So let's convert everything to lowercase before calling this function. So let's do 2 lowercase. Perfect. And now let's define our user input function. And just to see if this works, let's just write letter to the first of board state, so to the first cell, and let's pass in key. So let's evaluate this and let's try to write something here. Okay, that isn't working because our event listener hasn't been updated. Let's reevaluate our event listener. So now we can see that we are writing on in the first cell. Let's actually write to the next cell now. Let's figure out how to do that. And also to make sure that we only write letters A through Z. So the first thing we do is we put this into a conditional. So whenever we get a user input, the first thing we can check is that does our input matches A through Z. So let's write a quick regular expression for that, A through Z, and let's pass it the key. So when this matches, only then write onto the state. Let's reevaluate this and try again. Okay, now you can see I'm pressing 1, but it's not writing. So that's a win. But now I also want to kind of move to the next letter after 1 has been written. So let's add another state atom. So let's call it as counter, which starts from 0 and then it increments ahead. This is basically our position, right? Whenever we are pressing an A through Z, let's increment this counter. So let's do a swap counter increment. Okay, that isn't working since we're not really using the counter. So instead of first, what we want to do is we want to do nth and we want to use counter. Okay, so now if you observe, when I press a single key, right? When I press A here, I'm getting 3 A's. That's because our event listener has been attached multiple times. To fix this, what we'll use is we'll use def once and
2,000 years later.
Okay, so looks like our init once event listener isn't working. It kind of keeps adding this again and again. So let's change this a little bit. Let's call this a listener and let's create an atom here and let's store this. And what we can do is let's move this attaching of this listener inside our mount function. So let's go there. Okay, so I've added the input listener, and what I will also do is I will store it in the atom. Okay, so since we have it in the atom, what we can now do is we can unmount it we can remove it in the unmount call. So okay, let's see if this works. Yes, that did. So now on hot reloading, we don't get multiple inputs. What I would also kind of do is, instead of calling unmount here, what we can do is we can use shadows dev hooks. So we can add some metadata here, which is dev slash before load unmount. And what will happen is shadow will automatically recognize that this function needs to be called. And so this will only be called when we are using shadow in the dev mode. So now we can actually write beyond the first row. So let's fix that first. What we want to do is we want to make sure that the current counter is less than 5. So let's save and let's check. Perfect. But now if you want to move to the next row, we kind of want to attempt this solution. So we want to handle the case for entering. So let's do that now. Let's hit enter and that works. But we only want to be able to hit enter on the last attempt, on the last column. So let's add a condition for that as well. Perfect. Let's also handle the case where we backspace and we get rid of these. So we decrement the count on a backspace, but we also set the, we also write the letter on the current cell to empty. So AAA and backspace, perfect. Okay, the counter is actually going in negative, so let's fix that as well. What we want to do here is that counter should be greater than 0. Now to handle state for going to the next element, so that we can actually write further than 0 and 5, we want to introduce another variable, another state, which we can probably call as attempt. And here we can put the start and end columns, so end index for that particular attempt. So we are adding two variables here, which is start and end. So start starts with 5 times attempt, so it's going to be 0, and then it's going to be 5, 10, 15, and end is 5 times of attempt plus 1, so that's going to be again 5, 15. So we kind of get this range here. Instead of now doing less than counter 5, what we can do is we can do less than counter end, and instead of doing greater than counter 0, what we can do is greater than counter start. That's it. Let's hit save. Let's try something. Enter. Okay, now when we hit enter, we want to increase the attempt. So let's do that. And one more thing is that we don't want to kind of type this again and again to test this out. So let's improve that. If you notice, by design, we have this one function user input, which just takes a key. So it's completely abstracted out from the event listener. So we can actually simulate most of the events here. Let's try to do that. So let's create a string of events and let's call user input on all of them. Bam. And now you can see that this is copying our events. So now we kind of don't want to test everything by hand. So let's just call. So now let's wrap this in a do block so we can easily execute this. Let's add some more events to see what happens. Okay, looks like it gets stuck on enter. But when we hit OK, it kind of goes and does the next stuff as well. So let's get rid of JS alert now. And let's add code to actually color these blocks. So what we want to do here is, first we want to check the solution when somebody hits enter. So let's do that. And if the solution which we get, if the solution is true, that is, it does match the day of the word, we're going to say JS alert U1, and that's it. If the solution is false, we do nothing. So let's do this. So when the check solution needs to take the existing row, so we can use a subvec here. So let's do that, and let's pass the start and the end, and let's write this check solution function now. So check solution takes a bunch of cells, which is basically the row, and so check solutions takes a bunch of cells, right? But it also needs to know the day of the word. So let's again add another state, sorry, word of the day. Let's call our word as hello. And now inside of check solutions, let's do the most basic stuff, which is let's check if okay, so to get the letters from the cells, we first need to write another function, which is get letter, and we pass it a cell, and it should pass back the text content of that cell. And now when we do get letter map v to the cells, or maybe let's try to do take 5 from the board state, so we can just verify if this works, and it does. Yes, so the first 4 are empty. Let's add something here, and let's call this again. Okay, this works. So what we want to do here is map get letter cells. If this is equal to vector of the word of the day. If this is true, that means our solution works. So let's test this out again. Okay, it's board state. Let's enter our simulation now. And we did not get a success message, which is weird, because which is expected, because it actually enters HLK. So let's add one more simulation here, which is HELLO, enter, and let's simulate this again, and perfect, we've won. But we don't have the colors yet, right? We don't have these background colors, so let's figure those out as well. When we are checking for solution, before we actually return if it's a true or false, we can basically color our cells here. So let's do that. But our function color cell actually needs to also know which color to sell them, which color should the cell be. We need the index of the cell here, so let's use a map index to get the index of the cell. If I am correct, I think we can use a map indexed vector over here, and let's pass in both the index and the cell to the color cell function. And let's create a color cell function now, that if our letter is the same letter as the index of the word of the day, then that's it true. So let's color our cell as green, and let's add a color function here. So color, let's create a function, let's give it element and color. So what it can now do is it can set. So this should work. Let's test this out. Let's save, let's go back to our simulation, and nice. Perfect, that makes a lot of sense. Let's change the order of hello here. So let's actually do E, H, and OLO, and let's try it again. Perfect. So now we actually want to match and give these a yellow color. So let's go back to our conditional. If the letter contains any letter in the word of the day, so maybe we just need a contains function here. Let's put a set on word of the day. If this is contained by the letter, then we can just color it aqua. Otherwise, what we want to do is we want to color the cell as a light gray. Okay, let's simulate that and see. Perfect. So these attempts are colored light gray, this is aqua, and we've got our green. Perfect. And looks like that is it, folks. One thing which I really dislike about this solution or this approach is that we have a lot of mutable state going on, and we are still holding on to all of the DOM element references. So maybe in the next video, I'm thinking if we can kind of make this a little more declarative, maybe kind of use atom reactivity. So maybe add a watch and then diff the states and only make changes to the states when an atom changes. So we could probably do a lot more cool stuff here. So stay tuned for the next video if it ever comes. But I'm bored for now, so I'm not going to implement the keyboard here and not the animations. So yeah, thank you for watching.